In this demo, we are going to configure a first hop redundancy protocol. Specifically, we are going to configure HSRP in Cisco Packet Tracer. The network over on the LAN side is 172.16.10/24. The default gateway that's been statically programmed in the PC1 and PC2 is the .1 IP on this subnet, 172.16.11. The same thing holds true over on the file server side of the network. It is 10.10.10. The default gateway in the file server is programmed to be 10.10.11. Now, obviously, those addresses don't exist right now. If I go out to PC1 and I do ping 172.16.1.1, we get nothing back from 172.16.1.1. In fact, you can see up here, I ran ipconfig, and you can see that the default gateway is set to 172.16.1.1. And we let those play out like that, and of course it fails because that address does not exist yet. So let's go to WAN 1. Let's go ahead and configure the standby on the gigabit 00 interface. So the first thing we'll do is go to enable mode and show CDP neighbor. I always do that before I do any configuration changes, just to make sure I'm modifying the correct interface. In this case, we see that gig 00 points to the LAN switch, and gig 01 is connected to the server switch. Go to config mode, interface gig 0/0, and we're going to use commands under the standby command. We have to give it a group number. You don't necessarily have to give it a group number. If you don't, it defaults to standby group 0. It's always good to give a standby group number, even if you only have one standby group on an interface. You can have multiple standby groups on an interface if you happen to have multiple subnets behind a given interface. In our case, we only have one behind each interface. However, we're going to start off with the standby version. We'll set the version before we set any of the other standby parameters, just so we don't have any more resets than are necessary. So in this case, we'll do standby version 2, and then we'll go ahead and configure the standby group. So we'll do standby group 1, and we will say timers 1 and 4. So I'll actually back up and we'll show you what the two timers are. The first number is the hello interval in seconds. That's how often the standby group master sends out hello packets to all of the non-master switches saying, hey, are you on the network? And the same thing happens from the standby switches over to the master as well. It's used to determine that the switch is actually up and online. So we'll say that we're going to send hello packets every 1 second. By default, it's every 3. Most networks, you can throttle that back down. And the second number is the hold time in seconds, and that is how many seconds will go by between a hello packet before you consider that the sender of the hello packet is dead. You almost always want that to be at least 3 times the hello interval. That's the gold standard and the best practices. This defaults to 10 seconds. That way you have a little bit of jitter time just in case that third hello packet takes a little bit to get to you. In this case, we'll stick with that. We'll go with 3 times the hello interval and add a second to it. So standby 1 timers 1 and 4. And then we'll configure the IP address of 172.16.1.1. I actually have to put the IP command in there. So you'll see that it initializes there. In just a few seconds, it will come up to standby, and then it will eventually go into active. So there it is. It went from speak to standby, from standby to active. So now if we do show standby, we see that we are on gigabit 00 group 1. We're using version 2. There's the virtual IP address. There's the MAC address. There's the hello time and the hold time, and it tells you how long it is before the next hello packet is sent. Preemption is disabled, and priority is 100 of the default of 100. We'll get into preemption and priority here in just a moment, but let's go over to WAN 2 and do the same configuration. So to save you the drudgery of having to watch me retype these commands, I went ahead and did it. Those are the commands that I entered in. You'll notice that I didn't put the timers in there because we're using HSRP version 2. The secondary switch will learn the timers from the primary. So in this case, we'll do show standby. And we see that the state is standby. There's the virtual IP address. You notice that it says hello time is 1 second, configured for 3 seconds because we didn't change the default. Hold time is 4 seconds, configured for 10 seconds. It's saying those are configured for the groups because we left them at the defaults, but we learned these other timer values from the master router. If we do show standby brief, we actually see that we are in a state of standby. The active gateway is 172.16.1.5. The standby is local, and there's the virtual IP, just like we would see on the WAN 1 router. In fact, if we go out here and we do show standby brief, we see that the state is active, the active router is local, the standby is 172.16.1.6, and there's the virtual IP. So welcome into part 2 of the demo. While we were gone, I went into the WAN 1 and the WAN 2 routers and configured the HSRP standby group on the server side as well. This will become important here in a moment whenever we actually test the configuration. So now if we were to go to WAN 1 and do show standby brief, we see both standby groups on gig 00 and gig 01, each with the virtual IP of the default gateway. So if I've done everything correctly, I should be able to go into my PC1 and ping 10.10.1.100, which is the IP address of the server. And after a few seconds, we start to get replies back. That first packet almost always times out no matter what virtualization platform I use. And if we ping it again, it comes back immediately now that it knows where the device is. So we can verify that we can ping all the way across the network as we would expect to be able to. So now that we've gone to the trouble of configuring this, let's go ahead and test it out. So we've verified that traffic works all the way across the network from PC1 over to file server. So what happens if we just turn off one of these routers? Well, let's go into PC1 first off, and we'll go out to the command prompt. So we'll do a ping-t to 10.10.1.100. And after that first one times out, we see that we start getting continuous packets back. So now I'm going to go into WAN 1, which is currently the primary router. Let's verify that. First off, yes, this router is the active. And so now let's rearrange this a little bit so we can see both things here. And if I were to go to PC1 and watch the ping packets, I'm just going to turn this router off. And as we would expect, we start dropping packets because our default gateway has gone away. Now, after just a few seconds, WAN 2 will realize that I'm not getting any hello packets like I expect to, and I'm going to time out that guy, and I'm going to take over the virtual IP address. And there you go. There you see it. Just about 5 or 6 seconds of downtime all told. Now, again, that is an interruption in traffic, but I think 5 seconds of downtime is probably much more preferable to an entire floor or an entire section of the building being offline because the default gateway decided to let all the magic smoke out.